Hey everyone, I'm Nick, and this is C++ from scratch. So in this episode of the series, we're going to be talking about class templates. So in one of our previous videos, we looked at the basics of function templates, and we said that this was a nice and useful feature because it allowed us to offload some of our work to our compiler. So instead of, say, having to implement multiple different versions of some function for different types, we could instead write a template and generate these different versions using our compiler. Now we can do the same kind of thing using these class templates, so we can create more generic objects and containers. Now we've already seen a number of examples of this exact concept, and that's through our STL containers. So STL just stands for Standard Template Library. So StudVector is a good example of this. So at the end of the day, StudVector is just a class template that we can instantiate with different types. So we can have a dynamically sized array of integers, or one of floats, or one of doubles, or one of some user-defined type with a struct or class, because it is just a template, right? This StudVector is just a class template. So let's go ahead and see how we can write our own class templates today. So let's go ahead and open up a new example here called class templates. And we'll go ahead and start by including a few headers. So we'll include IOStream, so we can do some printing, and it'll also include our memory header, so we can use our std_unique pointer to manage some dynamically allocated memory. Then I'll go ahead and write a main function here, the core of our C++ programs. Now let's say we want to define some class template for a dynamic array. So we want dynamic arrays of any number of types, right? So of integers, of doubles, of floats, or of other structs or classes. So let's go and see how we can define that here. So we'll start off by just defining some struct called dynamic array. And then to make this a template, or class template, what we can do is above our struct here, or class if we were using classes, we can just use our template keyword. And just like with our function templates, we can use this type name t thing in order to say that our class template here has one template parameter t, right? So we can create different versions of this dynamic array for different types t that we can specify later. Okay, so for a dynamic array, we might want a couple of data members. So we might want to keep track of the size of our array. So we can have some integer, say size here. And then we can go ahead and use something like a unique pointer to manage our memory for us. So we can have some std_unique pointer that's going to manage a dynamically allocated array of type t here, right? Our template parameter. And we can just call this pointer. So then we can go about, say, creating a constructor for our struct here. So it'll just have the same name as our struct, so dynamic array, and maybe it takes a single parameter here, so some integer size, right? The number of elements we want to dynamically allocate for. Then we can go ahead and initialize both size and our pointer using our member initializer list. So we can go ahead and, let's go ahead and rename this to new size here so we don't have any confusion on names. So we can go ahead and initialize size with this integer new size here, that's our parameter. And we can go ahead and initialize our std_unique pointer here with a pointer to some dynamically allocated memory. So an array of type t with new size elements here. Okay, so we have a constructor here, right? We're initializing our size data member and our pointer data member to some with some pointer to a dynamically allocated array of type t with new size elements. All right. So below this, we can say, write a few helper methods or member functions that we might want for a dynamic array. So for example, we might want a fill method, right, that takes some value of type t, and we're going to fill our dynamically allocated array with this value. So we can just have a simple for loop in here. So for int I is equal to 0, I is less than size, the number of elements inside of our array, and then I plus equals 1. We can go ahead and index into our array here through this pointer. So we can do pointer of I is equal to value. So every element inside of our array will be set to value, right? That is of type t. Okay, so let's go ahead and write one more kind of helper function or member function here that we'll call, say, print. And this will just say print out the contents of our array. So again, we'll just use another for loop. So for int I is equal to 0, I is less than size, and then I++ here. We'll just do std_cout, pointer of I, right? So each element of our array separated by a space, and then afterwards, one new line character, right? So that we get a new line afterwards. Okay, so this is going to be our simple class template here, or the struct template. So we've created some type dynamic array that's templated with this type T here. We have two data members, some size, so the number of elements inside of our array, and then some unique pointer managing an array of type T here. Then we have a constructor here that takes some parameter new size, so the number of elements we want to dynamically allocate. So we initialize size with this integer new size, and we initialize our unique pointer with a pointer to some dynamically allocated memory. So a dynamically allocated array of type T with new size elements. Then we go ahead and we have a couple member functions. So a member function called fill to fill our dynamically allocated array with some value of type T that we pass in. And then we have some print method to just print out the contents of our dynamically allocated array. Okay, so let's see how we can use this templated class or struct with our different types here. So we can instantiate different versions of our dynamic array. So for example, we can create some dynamic array of integers. So we'll use these opening and closed angle brackets here to specify this template parameter T here, this type we want to instantiate dynamic array with. So we can have, say, a dynamic array of integers that we'll call int array. And we'll go ahead and create an int array with 10 elements here. So we'll pass that to our constructor. Then we can do, say, int array.fill. So we can use our fill method. Maybe we'll fill our array with the values 5. And then we can go ahead and say print out from our array. So we can do int array.print. So we can call that other function or member function. So let's go ahead and instantiate one more version of our dynamic array. So instead of a dynamic array of integers, we can do a dynamic array of, say, doubles, right? So double precision floating point numbers, right? And we'll call this double array. So here we'll also have, say, 10 elements. And then we can go ahead and fill this double array. So we can call double array.fill with, say, some double precision numbers. So 1.23, for example. And then we can call double array.print, right, to print out the contents of this double array. Okay, so that's going to be the basics of our example here. So we defined some class template here called dynamic array, right, using the struct here. We have a couple of data members, a constructor here, a couple of member functions. We create a version of our dynamic array for the type integer and call our methods. And then we create a version of our dynamic array for type double here and call those methods here. So what we're doing is we're relying on our compiler to generate different versions of the struct for these different types that we've specified down here. We're offloading that work to our compiler. Okay, so let's go ahead and save this, and we can go ahead and compile this class templates with G++ and call our output executable just something like class templates. Then we can go ahead and run this example, and what do we see? Well, for int array, right, we have 10 elements here, all integers, and we use that fill method to set all the values to 5. And we did something similar for our double array here. So our dynamic array using this double precision type, and we print out all 10 of these 1.23 values that we filled that array with. Okay, so that's going to be the basics of how we can create and use these class templates. So these class templates are an incredibly powerful thing, and we see them all over C++, namely with our standard template library. Now, of course, there's a lot more that we can get into here with our class templates and how we can define these templated classes and how we can specialize them, but we'll reserve those for later videos in the series. Now, as always, you can find this and any of the other examples at github.com/coffeebeforearch. So you can find this CPP from scratch repository containing all these examples. And I'll also make sure to link down this CPP reference page for class templates below the video. But that's going to go ahead and do it for today. As always, I'm Nick, and I hope you have a nice day.